Hello guys, my name is Patrick Mensah and today I am going to talk about scatterplots. So when we talk about a scatterplot, what do we mean by a scatterplot? A scatterplot can also be called as a scatter chart or a scatter graph, and it uses dots to represent values for two different numerical variables. So the position of each dot on the horizontal and the vertical axis indicates the values for an individual data point. That is, scatterplots are used to observe the relationship between two variables. So the variables cannot be categorical variable. It can only be continuous variable. What do we mean by continuous variable? A continuous variable is just a variable that contains numbers. It cannot contain logical variable like true or false, or it cannot contain categorical variable that is like variables with levels. Let's say our race, which is like black, white, so many different colors. But regarding scatterplots, we can only use numerical variables, and it shows how the relationship between the two variables, whether it has a positive relationship or a negative relationship. So now let's look at how we can actually do that. One thing that I want us to do is I'm going to show you a data, and then I'll show you how to import the data into our programming, and then we see how we can do scatter plots. So let me share the screen. Let me show you the data. Okay. So this is the data I'm going to talk about. This data is called a Google search data, and then it contains states in the United States. We have 50 states in the United States. However, regarding this data, 2 of the states have been removed for some reasons. And if you want to look at, if you want to search for the missing states, we have a code that we can run to do that. But that is not the focus of this video. So when you look at the states, the psych regions, like whether the state is friendly or conventional, whether it is relaxed and creative, whether it's friendly. So they tell you everything. So this tells you that if you want to move to a different state, you can look at it. Like, for example, I am in Connecticut, and then my psych region is temperamental or uninhibited. So that is that. And then we have the extraversion, agreeableness, consciousness, and everything. Facebook, retweet, entrepreneur, and so many others up to modern dance. So I am going to show you how to import these data sets into our programming, and then we will handle that. So let's go back to our programming, and then let's see how we can handle this data. Okay. So if you want to import the data sets, there is something called Pacman, and then Pacman is a package that we use to load so many libraries. So for example, if you want to run a program and then you have a lot of libraries, the Pacman is going to help you to actually use only one line to import the libraries. So let me show you how it is done. So you call for the Pacman, then you say p_load, because we are going to load the libraries. So what libraries are we going to use? We are going to load Pacman. You are going to use Rio, which helps to import data. And then we are also going to use tidyverse, because we are going to use tables and then piping. And Python and everything are also fine in tidyverse, because if you don't install a library, it's going to give you a problem. So let's install. Let's do tidyverse too. So tidyverse is here. So now we have been able to load Pacman, Rio, and then tidyverse. So let's run it. So you run it, and everything is showing here. Now it tells you that everything is run. Now we have to load and prepare our data. And I told you that the data is called Google Search Data. So we can name the data Google Search Data. So we say Google.search data. Then After that, then we use the import function, and the row is the one which is going to help you do that. The data is called a state data. So the data I showed you, so this data is called state data. State, data. You have to do it, and then the extension of the data is XLSS. So you say XL SX. That is a file extension, and then we after the data, you have to install it as piping. You have to pipe it, and then you save it as a table. So we do the table as table. Then after you have done that, another thing you have to do is to use the piping again. Then we are going to select some of the variables. So let's say we are going to select, which are you going to select? We are going to select, let's say, the state code, the state, and that's called code. And then the psych regions. So you say psych, psych regions. Okay, it's here. Then we are saying Instagram. They are all part of it. So Instagram, you know, typing all these things is going to give you a lot of problems. So if there is one thing you can use to cover all of them, all the data. So one thing you can do is to use this semicolon, and then it's going to so it's going to run from Instagram to modern dance. So Instagram to modern dance. So after you have done that, then another you have to do is to pipe it. So when you pipe it, then you know the cycle regions, they are categorical variables. So because of it being categorical variable, you have to use as factors to make it factors. So we use the function called mutate, and the tidyverse is going to help you do that. So you use the mutate, then you say psych region. Psych regions. So it should be, you save it as factors. So as those factors, then you say psych regions. So after you have done that, one thing you have to do is to show your data. And if you want to show your data, we pipe it and we say print. Print. So let's look at the data. We run it. Oh, okay. It's telling you, it gives you an error over here. So this error is telling you that one Instagram does not exist. So it means I didn't type the Instagram well. So let me type it well, and then we run it. Yes. So now it has been able to tell me that tell me the data. So now, if you want to view the data like I showed you initially, you can view the data like this. So we view the data. So we view and then say Google search data. And then you press the command and enter to look at the data. Now you can see the data over here. Very, very nice. This is how we import the data into our programming. So now you can see the data and everything. Or you see all these things, I didn't do all of them because I used the semicolon function to call for all the data. Very, very, very nice. So now what you have to do is, now we are going to do the scatter plots. So now, if you want to do the scatter plots, we use the plot function to do that. So let's assume that we are going to do a scatter plot from Instagram, from Instagram through, because the Instagram, all these are categorical variables. So I don't want to talk about it. I told you initially that if you want to do scatter plots, you have to use continuous variables. So you don't have to use categorical variables, else it's going to give you something wrong. So we are going to start from Instagram through modern dance. because the cycle regions, I shouldn't be part of it because they're also categorical variables. So this is how we are going to do it. So you said Google search. We have so many ways of, anyway, we have so many ways of doing scatter plots, but I'm going to show you a simple way to do that. So you do that, you call the data and then you pipe it. So when you pipe the data, then we are going to select the data. What are we going to select? So we are going to select Instagram through, which I showed you, through modern dance. Then what do? We pipe the data. I want to do it so slowly so that you know what is going on, and we plot it. So now we are going to, this is going to show you a plot of all other associations. So you look at it, then you run it. You see now it has given you everything here. You can't see it very well. So let me zoom it. So I'm going to try to zoom it. So when you zoom the data, this is how it is going to give you it. You see that you can see the names and everything over here. It tells you the relationship between this is the data like Facebook. This one is telling you that this is the scatter plot between Instagram and then Facebook. This one is telling you that this is a scatter plot between retweets and then Instagram. So it runs from here. Everything that is over here is the same thing that is at the upper side. So we have our focus is not on making sure we do only one side. There is a code for that, but that is not our attention. Let's look at this data over here. So this data is telling you that it is from a scrapbook and then a modern dance. So we have this data over here. And we were going to focus on this data and then see how we can do that. So now let's go back to our data, our arrow, and then we look at how we are going to work on that. So now we have been able to plot all the associations and look at it. So you see that the one that I showed you, it shows that it's slight as it moves forward. Okay, don't worry about it. I'm going to plot it again for only the two. So now we are going to show you, I'm going to show you a bivariate scatter plot with default, and I'm going to do only the modern dance. I showed you that is the modern dance, and then the modern dance and the scrapbook. So let's look at how we do a bivariate scatter plot. So with the default one, so we say we call the data, then we pipe the data. Sorry, you pipe the data. After you pipe the data, they're going to select only two. They're going to select the scrapbook, and modern dance. Then regarding that, we also pipe it again. Then we plot it. So when you plot it, this is how it is going to show you. This is by default. So by default, here you can see that the relationship between modern dance and then the scrapbook is here. So you can see that it's sloping. So it means that everything is up from the beginning, and as the scrapbook moves forward, everything reduces. So basically, it's like an inflation. So when there is an inflation, everything is high. The cost of everything is high. So as time goes on, as time goes on, everything comes down because of good management. So everything comes down. But all of a sudden, there is one point over here, and this is what we call an outlier. This is what we call an outlier. Now, if you can't see it well, I am going to show you. Okay, so another way you can also do that is very simple. Just because I said I use this one, you can also use another method. So you can just okay, I think I have already done it. I have already done it. Oh no, okay, so there's another method of doing that. So let me just copy this code and I just paste it. So, and then I'm going to use this formula, this semicolon. So this semicolon is telling you that from scrapbook to modern dance. So when you look at your data, let's look at where scrapbook is located. Scrapbook is here. So scrapbook and this, they are just closer. That's why you can also use that. But if it is like museum to this, and then you use that, it is going to take care of the scrapbook and the data and the modern dance. But just because the scrapbook and then the modern dance is just closer to it, that is why it's going to take only the two variables. So let's go back to our data, and then we use this formula and then run it. It is also going to give us the same thing. It's basically give us the same thing. Now, let's look at how we are going to do. We are going to run a bivariate with options. So now, let's look at which contains almost everything. So if you want to do that, we call for a data. We call for the data, and then we pipe it. Then after you pipe it, then you select how many, which one are you going to select? You are going to select the same thing. So we select scrapbook, then we are going to also select the modern dance, because that is our attention. Then after you have done that, you pipe it again slowly, and then when you pipe it, then you can plot. So what are we going to plot? So now we can add options to it. So the title, which you use the main, then you call for the equal to sign, then you say scatterplot of let's say scrapbook and modern dance. Okay, let me just add it together. Modern dance. So that is so after you have done that, another thing you can do is to call for the X column. So the X column is here. So you call for the X column. Then how are you going to name it? So we say scrapbook, and then we can also call for the Y, which most of the time we use frequencies, but you just want to use a different name. So the name is also called modern dance. So modern, let me combine it together. Modern dance. So another one thing I like about our programming is when you do a plot, you can do you have to add colors to it so that you can see everything clear. Even though this one we can see it, but let's add colors to it. So you add colors, and then you say which colors are we going to use? We are going to use rainbow colors. You can also use terrain colors to do that. So we are going to use rainbow colors, and then 6. Then there is something called PCH. PCH is going to tell you how you are going to draw the plots. So let's say I'll show you what PCH is. So PCH, you say PCH, let's choose 20. I'll show you why I chose 20. So let's run it and see. So now it has given us almost everything. The colors are here, the scrapbooks are here, modern dance are here, the topic is here, and then we can see that outlier. The outlier is still there. The outlier is still over there. So let me show you why I chose PCH to be 20. So if you want to know more about PCH basically is called plotting character. That is PCH. So plotting character. So if you want to know more about PCH, you use this question mark and then say PCH. Then you run it. So when you run it, it tells you that is how we add points to we add points to a plot. So it has numbers. The reason why I chose numbers, let me show you. Everything is here. So if you choose 0, this is what it's going to give you. So initially it tells you that it selected 1, but I chose 20. So 20 is supposed to be this. If I hadn't added the colors, it would have shown something like this. But because I added the colors, that is the reason why you actually saw the plot like this. So now let's try to add, let me go back here. Let's try to add a fit linear regression to it. So the fit linear, I will talk about regression, but not now, but I'm just showing you a fit linear regression that is going to show you something that it's going to show you something. Let me show you. So we are going to add that, because we're going to add a line to it. So we are expecting a line to be drawn like this, so sloping down here. But look at how, because of this outlier, because of this outlier, I'm going to do something, and you are going to see how it is going to do. So we are now, I said we are going to add a fit linear regression line. So if you want to add a fit linear regression line, this is how you do it. You call for the data. Oh, sorry, this is not the data. So you call for the data. This is the data. Then what to do is to pipe it. Then after you have pipe, then we call something linear model. That is linear regression. When we get to regression, I'll show you how it is done. So you call for the modern dance data. Then we use something called tilde, and tilde is telling you that this one should be the response variable. The modern dance should be the response variable, and the scrapbook is supposed to be the dependent variable. So then after you have done that, then we call for the data. We have already called for the data, so we use dots. There is another way for doing that. When we get to regression, I will show you how it is done. So you do tilde. Then after you have done tilde, then we add a line, and then that line is called add line. So you call for the add line. Now we have done that. Let's add the point. So now look at the line over here. This line, we were expecting a line to cross like this, but because of this outlier, this problem over here. So it's like you are doing a business, and that business, or you are running a country, and there is one problem over here. There is a corruption over here. We have so many ways of dealing with the corruption. Now you have to expose. Because we don't know who is doing that corruption over here, or the bad nuts over here. So now let's look at how we are going to expose, because you need to identify the outlier before you can deal with it. If you don't deal with if you don't look at it and then do it, now one problem is going to give you is that this one, when you do KK plots, that is it's going to show you whether it follows a normal distribution. It also follows, it has constant variance, because every data, we expect a normal data to be normal. It should follow a normal distribution. It should have a constant variance, and so many other stuff. But this one, because of this outlier, this is not going to show you. It's not going to be normally distributed because of this problem over here, this corruption over here. So let's look at how we are going to. We have to expose this corruption and see who is that. What is causing that problem? So when you look at the graph over here, when you look at this number is 4, and there is a number over here. So we have that number here is greater than 4. So let's look at how we are going to do that. So by identifying it, we call the data. So once you call the data, then you pipe the data. So when you pipe the data, then you select it. So I'm going to select this one. You can select any variables to identify, identify it, because we are looking for the scrapbook. So we can just select one data, and then so let's say we are going to use the state code. So let's say state code, state underscore code. Then you also call, after if you call for it, then you call for the scrapbook, because the scrapbook, that data is in the scrapbook. It's in that column. So after you have done that, then what you have to do is to pipe it again. Then let's bring it down here. Let me give more space so that you can see it. So you put it here, and you bring it down here. So when you bring it down here, then you filter it. So we call something filter. So filter. So when you filter, you have to filter that data is in the scrapbook. So it is in the scrapbook, and then that data it's more than 4. So that data is greater. So you see that data is greater than 4. So that data is data for. How do you see that? So you have to pipe it again. So by piping, after you have piped it, then you print the data. So you print it. Let's see whether we are going to see the data. You pipe it and you can see it here. It is UT. That is UTA. It's a UTA. Then the scrapbook is this, and this is what is giving you the problem. This is the corruption in the data sets. This is the problem over here. It's like if you are doing a business and that business is not one of the variables, one of the business you are doing, the things that you buy and restock it, it doesn't sell. So it's spoiling your business. So let's look at how we are going to handle this business. We have to deal with that. So this is the outlier. So there are so many ways of dealing with outliers. We have been able to expose it. Now we have so many ways of dealing with it. Outliers is a full topic. I will talk about outliers, but one thing you have to do is, let's say we are going to remove this bad nuts, this problem, this thing over here. So now we are going to remove this one. We are going to remove this one from the data, and then we look at it. So now let's look at how we are going to remove the data. It is very, very simple. So what you have to do is that you call for the data sets. I don't want to type again because it may be, okay, well, anyway, I mean, let me just copy this one. Okay, no, don't worry. Let me just copy. There are so many ways of doing it. Let me just copy it and paste it over here. I have pasted it. So this one, we are going to look for the data, and then we filter the scrapbook. We are going to filter the scrapbook. After we filter the scrap, oh no, we are not going to. Okay, let me just type it because I don't want to select this one. I don't want to select this. I can select. I'm going to select the how do you call it? The modern dance data. I mean, it's still the same thing. So it's still the same, but the only thing is I can change it over here. But don't worry about that. I'm telling you how to deal with that. So let me just delete it and then do that. So what you have to do is the same. What I deleted is what I'm doing, but I'll just maybe pick some few changes. So here you call for it, then you pipe it. So when you pipe it, now we are going to select. Oh, sorry. We are going to select the scrapbook, and then we also select the modern dance data. The modern dance data. So once you have done that, you pipe it again. So you pipe it again. Now we are going to filter it. So we are going to filter. And now after you filter it, we are going to filter and then select the scrapbook because that is what we are. Sorry. Scrapbook. And then now we are going to select all of them. We are going to filter everything and then leave that four over this 4, this number that is 4. And then what you have to do is to use less than. So less than is going to filter all the data without the 4. So we do that, then we select that. So after you have done that, now you can pipe it again. So after you pipe it, now you can plot your graphs. So let's plot it. So we plot, then we add the mean. So after the mean, then we say scatter plots. We say scatter plots of scrapbook and modern dance. Scrapbook and modern dance. Nice. So another thing we can do is to call for the X lab. So the X lab is here. The X lab is here. So we say the X lab is called scrapbook. Oh, what am I? How am I? Scrapbook. And then our Y lab YLab. Okay, let me bring it down here. Come on, let me say YLab. We call it modern dance. Modern dance. Then we add our color. Okay, so we say rainbow colors because I like it. Rainbow colors. You can use another different colors. And then now after you have done that, we choose our PCH because the PCH is very, very important. So the PCH, we choose 20. 20. Now let's plot it and see. Yes. So now look at it over here. We have been able to remove the outlier which was here. So now look at the data. Look at how it is sliding. So if like for example there is an inflation, and now once everything is working well, now you can see that everything is moving on well. I'm not saying you can. There are so many ways you can handle inflation. The outlier. You can also model it and then square it. You can exponentiate it. You can do so many things with it. But we are assuming that you are removing it. So when you remove it, you can see a straight. Everything is falling down, and as time goes on, it is just going down. So now let's add our filters, because you need to add the filter so that you know we add the line so that you see whether how the line is flowing. So now we call the data set. So when you call the data, let me bring it down. I don't want to bring it. And then give more space. So you call for the data set. Then you pipe it. So when you pipe it, then we are going to filter. So filter. We are going to filter scrapbook. Scrapbook. Then that data is less than 4. Then after you've done that, you pipe it again. I like piping. Then you find a linear model. So, okay, let me bring it down here. So linear model. Then once you do that, you call for the modern data set, modern dance, which is the response variable. Then you tilde on scrapbook. Scrapbook. So after that, then you call for the data because the data is already there. So you call for the data and you use dots. Then you add the line. So we use this one to add the line, and then we use add line. Now let's run it and see. So after running it, look at how it is doing. So you can see that because of just one outlier, because we were able to deal with that line, you can see that by drawing the line is just flowing downwards, and it is going to flow downwards and downwards and downwards and downwards. So if you're having in a nutshell, if you are doing a business and you see that you have a problem with one of your variables, you are doing a business, you are running something and it's not going well, something is wrong with that. You have to deal with it. You have to deal with it. You can. There are so many ways you can do with it. So this one, we do away with it. So if there is a corruption over here, like for example, the Ejapadel was here, and they were supposed to do something about it. Nobody, they were handling it and they couldn't handle it well. So if that corruption is there, and then you are not able to deal with it, and then you do that, the line was still going to be straight because it's going to escalate. Everybody, they will think that if they didn't go ahead to do the corruption, and it will go on and it will go on and it will go on. When you do your QQ plots, the QQ plot is going to show you so many distance. You are not going to have a normal distribution. You are not going to get constant variance as it goes on. So now you look at this data. I haven't done the QQ plot, but look at this data over here. You can see that when we draw this line, right, the dots that you are finding down here, you are almost finding the same dots up there. So it is telling you that when you do a QQ plot, you are going to get a constant variance. This is how we do scatter plots. Thank you so much, and Don't forget to subscribe to my channel. I appreciate your time.